In this clip, we're going to be looking at simplifying algebraic fractions. There are three different types. This type of question, where we just have to do straightforward cancelling. This type of question, where we need to factorise before we cancel. And this type of question, where we've got to add or subtract some fractions. You'll find that at least one of these types of questions is on almost every single exam paper. Let's start by looking at how we do the questions that just involve straightforward cancelling. I'm going to show you two different ways of doing this question. The first way looks like this. I start with 6 divided by 2, and 6 divided by 2 is 3, so I write that down. Then I've got n squared divided by n to the power of 6. To do this, I subtract the powers. 2 take away 6 is minus 4, so I've got n to the power of minus 4. Then I've got m to the power of 6 divided by m to the power of 2. I subtract the powers again. 6 take away 2 is 4, so I've got m to the power of 4. And this would be my answer. The second way is where I cancel, and it looks like this. What goes into 6 and 2? Well, 2 goes into both of those, so if I divide this by 2 I get 3, and if I divide this by 2 I get 1. What goes into n squared and n to the power of 6? N squared does. If I divide this by n squared, I get 1, and if I divide this by n squared, I get n to the power of 4. What goes into m to the power of 6 and m to the power of 2? M to the power of 2 does. If I divide this by m to the power of 2, I get m to the power of 4, and if I divide this by m to the power of 2, I get 1. Now I can tidy up my answer. I've got 3 times 1 times m to the power of 4, so that's 3m to the power of 4. And on the bottom, I've got 1 times n to the power of 4 times 1, so that's just n to the power of 4. Both of these answers are correct, they're equivalent to each other, and they're both completely acceptable in the exam. For this question here, I start with 8 divided by 2, and 8 divided by 2 is 4. I've then got x plus 3 squared divided by x plus 3. Remember that x plus 3 is actually just x plus 3 to the power of 1. So I can subtract the powers, 2 take away 1 is 1, and that leaves me with x plus 3. It's really to the power of 1, but I don't need to write that. So this is the answer. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now in this question, I've got an algebraic fraction that's made up of a quadratic and another quadratic here. To simplify this, I first of all need to factorise each of these. So factorising the top gives me x minus 5, x plus 3. And factorising the bottom gives me x minus 7, x plus 3. Now you can see that I've got x plus 3 on the top and on the bottom, so these will cancel out and I get x minus 5 on the top and x minus 7 on the bottom. This is my fully simplified fraction. For this question here, I'm going to start in a similar way by factorising the top and the bottom. So on the top here, I can see that I can take out a factor of 3x. That leaves me with 3x minus 2. On the bottom, I can take out a factor of 2, and that leaves me with 9x squared minus 4. Now, 9x squared minus 4 is a difference of 2 squares, so I can factorise this again. So on the top, I've still got 3x and then 3x minus 2. And on the bottom, I've still got the 2, but then with a difference of 2 squares, I have 3x plus 2 and 3x minus 2. Now I can cancel the 3x minus 2 on the top with the 3x minus 2 on the bottom, and that leaves me with 3x on the top and 2 brackets 3x plus 2 on the bottom. This is my fully simplified answer. Now the absolute key to getting this answer was spotting here that I've got a difference of 2 squares. This comes up quite a lot on the exams, so you need to get really good at spotting them. We've got 2 square numbers here and a minus in between, and that tells us we can factorise it in this special way. If I didn't spot this, I wouldn't have been able to finish the question. Another key point for this type of question is noticing that you're definitely on the right track when you get a matching bracket on the top and on the bottom, like we did here and here. If you don't get this matching bracket when you're trying to do one of these questions, then you may have made an error somewhere. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now we're going to look at the third type of problem, where we're asked to either subtract or add 2 algebraic fractions. Now, when we're subtracting or adding normal fractions, we look for a common denominator, and we're going to do the same thing here. So for this first question, I say to myself, what will 2 and 3 both go into? And that's going to be 6. So I'm going to write 2 new fractions, both over 6. How many times does 2 go into 6? Well, it goes in 3 times. So on the top here, I need to multiply by 3. I've got 3x plus 2. In the same way, this side needs to be multiplied by 2. So I've got 2x minus 1. Now I can rewrite this as one single fraction. I've got 3x plus 2 minus 2x minus 1, and that's all over 6. Now I'm going to multiply out the brackets on the top. So I've got 3x plus 6 minus 2x minus 2 times minus 1 is plus 2, and that's over 6. Now I'm going to simplify the top. So I've got 3x minus 2x, which is x, plus 6 plus 2, which is plus 8, and that's over 6. I can't do anything else to this, so this is my answer. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Now let's make it a little bit more difficult. This time, in the denominators, I've got letters instead of numbers. So when I'm looking for my common denominator, it's actually going to be this multiplied by this. So the common denominator is going to be y x minus y. So I'm going to write 2 fractions with this as the denominator. Now to get this to this, I've multiplied by x minus y. So I multiply 3 by x minus y. To get this to this, I've multiplied by y. So I multiply 2 by y. Now I can write this as one single fraction over y x minus y. So I've got 3 brackets x minus y plus 2y, and that's over the common denominator of y x minus y. Now I'm going to expand the bracket on the top here. So I've got 3x minus 3y plus 2y over this y x minus y. And now I can simplify the top. So I've got 3x minus 3y plus 2y is minus y, and that's over y x minus y. Just out of interest, at this point here, I expanded this bracket but not this bracket, and that's because I saw that the 3 and the y would combine and simplify with this plus 2y, but that I wasn't going to get any further simplification from the bottom. And this is the simplest form of my fraction. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another question for you to try. Press pause and have a go at it. When you're ready, press play. Now, if you're really good at algebra, then you will have got to this stage here. And you've certainly written it as a single fraction, so you will get some marks on the exam. But believe it or not, it's not in its simplest form. There's actually a factor that will go into this cubic on the top and that will cancel out with the bottom to make it in a simpler form than this. The problem is, if you've tried to do it this way, finding that factor is incredibly difficult. So I'm now going to show you a slightly different way of doing this type of question where we've got a quadratic in one of the denominators. So the first thing to do when you've got a question like this with a quadratic in the denominator is to try to factorise that quadratic if you can. So I'm going to do a bit of side working first. I'm going to write out my quadratic, that's x squared minus 1 in this case, and I'm going to see if I can factorise it. Well, I definitely can because this is the difference of two squares. So it factorises as x plus 1 and x minus 1. So I can now rewrite the question as 2x over x minus 1 minus 7x minus 3 over x plus 1, x minus 1. I now want to find a common denominator, and the nice thing about these questions is that it's going to be this one here, the quadratic that you factorised. So I rewrite this as two fractions, both with x plus 1, x minus 1 as the denominator. Now what have I multiplied this by to get this denominator? Well, I've multiplied it by x plus 1. So I've got 2x and x plus 1 on the top. This one hasn't changed, so I've got 7x minus 3 on the top. I'm now going to write this as a single fraction with x plus 1, x minus 1 as the denominator. So I'm going to put the denominator first, and then for the numerator, I have 2x, x plus 1, minus all of this. So that's minus 7x, but it's minus 3, so that's plus 3. You need to be really careful here. I'm now going to expand this bracket on the top. So I've got 2x squared plus 2x minus 7x plus 3, and that's over x plus 1, x minus 1. Simplifying gives me 2x squared minus 5x plus 3, and that's over x plus 1, x minus 1. Now you might be tempted to stop here, but it's a good rule that whenever you've got a quadratic, you should try to factorise it, because you might then find a common factor that you can cancel with the bottom. So I'm going to factorise this quadratic, and I'm going to do that as a bit of side working. So I've got 2x squared minus 5x plus 3, and I want to factorise this. I get 2x minus 3, x minus 1. So now I can rewrite this as 2x minus 3, x minus 1, over x plus 1, x minus 1. And we can see that we've got x minus 1 in the numerator and the denominator, so these will now cancel out to give me my final answer, which is 2x minus 3 over x plus 1. Finally, here's one more question for you to try. Press pause and have a go. When you're ready, press play. Here's the answer.